Example 5, F triple prime, so this gets into that CDE situation, so what I just mentioned in the last example is going to happen in this one. F triple prime, again, I'm going to find F double prime, make everything pretty, find F prime, make everything pretty, find F, make everything pretty. So it's going to be, each derivative, antiderivative is going to be anti-differentiate by the formula, make the terms prettier by simplifying fractions and stuff. So, F triple prime, so F double prime of x equals. Alright, so I'm going to take 2x, I'm going to raise the power by 1, I'm going to divide by the new power. And this term is x to the 2/5 power. Keep in mind fractional powers are better than radicals when we're anti-differentiating. Alright, and I'm going to get x to the 7/5 times 5/7. Alright, so again, over 7/5 over 7/5 is the same as times 5/7. And again, there's this plus 0 that's right there, so I'm going to do a plus c to account for it. And then I want to make each of those as pretty as possible. I can't make 2/3 or 5/7 any prettier than 2/3 and 5/7. So that's ready to go. All right, that happens sometimes too, where your antiderivative formula just happens to get you the simplified answer. So we move on to f prime of x. So I'm going to get 2x to the 4th over 12. Okay. Officially, it's divided by 4, right? The 2/3 is already there, so the 3 and the 4 on the bottom become 12. If you wanted to do it this manner, you got your 2/3 that's already there, right? And you 4 divided by 4, it goes on the bottom. We're going to simplify this. It doesn't matter if you make it 12 immediately or whether you leave it as 3 times 4. Now, when you start getting these fractions, I make my fraction bar a little bit bigger because you're going to get stuff on top and bottom. So I'm going to write my 5/7 that's already there, right? This x is going to be to the 12/5. And I got to divide by 12/5, the same as times 5/12. The 5 and the 12 that are being multiplied, multiply the top by 5 and the bottom by 12. So the top was 5 and 7. Top's being multiplied by 5, bottom by 12. Then I'm going to get Cx, right? Because C is a constant. Stick an x on a constant. Again, there's officially a plus 0 there, so we're going to account for that with a plus d for this. And then again, once I get to this point, I want to simplify as much as possible, make this derivative, f prime of x, as simple as possible can be. This 2 reduces that 4 to a 2. So f prime of x for that becomes x to the 4th over 6. This becomes 25x to the 12/5 over 84 plus cx plus d. And again, there's officially a plus 0 there because there could have been some constant in the original function whose derivative is 0. Okay, every term's as simple as it can get. Start to just like this, but it's about to get uglier. So f of x equals, so the first one, I've got 1/6 already, right? X goes to the 5th power, and we're going to multiply 6 times 5. So the new power is 5, right? We divide by the new power. It goes on the bottom with the thing that's already down there, the 6. Minus, and again I got a fraction, so I'm going to make my bar a little bit longer, 25 over 84 x. Okay, this is going to be the 17/5, right? So if I'm taking the 17/5 power, I have to divide by 17/5, which is the same as times 5/17. Alright, this is cx to the 1st, so it's going to be cx squared over 2. That's just a constant, so dx, and that's 0, so plus e. I don't know off the top of my head what 17 times 84 is. 17 times 84 is 1428. So, write that before I forget it. Okay, so f of x in simplest form, reduced as much as possible, x to the 5th over 30 minus 5 times 25 is 125, x to the 17/5 over 1428 plus cx squared over 2 plus dx plus e. When you get get a higher derivative like that, a third derivative, and you have fractions in it, they're pretty unfriendly usually. I mean, a lot of times, you write down on your paper what you're supposed to do, and maybe you need a calculator to help you evaluate it, but do it correctly, that's the key. Pay attention to detail in your process. Don't forget the plus C's. Seeing test answers where it looks like that, they look at all this stuff here. It's really important. So make sure that you're careful with the C's showing up when they're supposed to. And again, mostly it's power rule, but again, your trig derivatives, know your 6 trig derivatives. Secant squared, cosecant squared, secant tangent, cosecant, cotangent, sine, cosine. If you have any one of those 6, they have an antiderivative. If they don't, if you don't get one of those 6, then we go back to chapter 6 from geotrig with the trig identities and all the modifications of things that allow you to change from one form to another to create the form you're looking for. That's when they get more challenging. All right, so keep that in mind. It's not going to happen today, but during this section, chapter 5 is where actually antiderivatives start showing up for real. You might have to do some trig identity or some modifications of trig expressions. So be ready for that.